Let's talk about class attributes and methods in Python. We saw instance methods earlier that access and modify the independent data associated with a specific instance. That is, we could make a car class and then have make, model, and year attributes, or methods like compute age, that refer to the specific instance of a car that we're talking about, rather than the full blueprint. Car 1 and Car 2 here, for example, have different makes, models, and years. That having been said, what if we want to share data between all the instances of a class? For a first example, we might say, well, cars have 4 wheels, so maybe we want to define a wheels attribute that's accessible to all instances it would create for a car class. A class attribute is accessible and modifiable by any instance of a class. Class attributes can be defined anywhere outside the methods within a class. However, normally, we place them right before the init method, like this. So after the definition of the class and before our initialization. Only one copy of the wheels attribute is shared between all objects. Any changes made to that variable will be reflected in all of the other objects. Similar to instance attributes, we can modify and access class attributes by using dot notation on any instance of the class, or by using the class name dot the attribute name. So, for example, we could say big C car dot wheels. Let's look at an example. We have a couple cars here. We see that car 1 has 4 wheels and car 2 has 4 wheels. We can also see that the car class as a whole has 4 wheels. Keep in mind that if we want to modify our car attribute of wheels, for example, by setting it to a string like this, that's going to set it on every single instance of our class. Now, here's the thing. In practice, an attribute like wheels doesn't really make sense as a class attribute. If a wheel falls off of one car, that doesn't mean that none of the cars should have 4 wheels. Since all cars can access a class attribute, and any car can modify it, it makes sense for us to use class attributes for something that all cars should know and any car could contribute to. So a good example of where we might use a class attribute might be something like a registry. Take a look at this code. We have a car class and a registry, which starts out as an empty list. But each time that we initialize a car, we ask that car to add itself to our registry attribute. That means that all of the instances of the car will be recorded in the registry of the car class. That means that we can use that registry for things. For example, we might have a method called contemporaries, which will return on any given car all of the other cars that were made in the same year as the car in question. Let's look at an example. We've got 3 cars here, one that was made in 2019 and 2 that were made in 2006. If we call contemporaries on car 3, it should give us, let me run the code. It should give us a list of cars that includes, look at that, car 2. Now, if we were to call contemporaries on car 1, which doesn't have any cars in the registry that was made in the same year, we should get an empty list here. So that's one way that we might end up using class attributes. Now let's talk about class methods. We can also define class methods, which are methods that are accessible to all instances of the class. There are a few things to note about class methods. First of all, class methods cannot access the instance attributes of a class. So, a class method on car couldn't access the make, model, and year attributes. Also, the first argument to a class method isn't self, but rather CLS by convention. You can name it whatever you want, but CLS refers to the class object instead of any individual instance of the class. The third thing to note about class methods is that you can access class attributes in class methods. So not instance attributes, but yes class attributes. Let's talk about an example by defining a class method that returns a string that indicates the number of wheels for the car along with, say, a PSI, tire pressure for the car. So in an example like this, we might want to be able to print out car has 4 wheels with a tire pressure for each wheel of 35 PSI. Now, to define a class method, you place the class method decorator before the define statement when defining a method. Let's look at an example. We have these 2 class attributes right here, wheels and PSI. Now, as we've established, wheels and PSI aren't really good examples of what we might use a class attribute for, but we're using them here for teaching because they're very simple, they're just integers, and that way we can reduce the amount of complexity associated with showing you how class attributes and class methods work. So, we have our class method down here, which you know because, first of all, it has its class method decorator right there, and the first attribute that we pass in, or the first parameter that we pass in rather, is class. What we do from here is we return a string which accesses the class attribute wheels and the class attribute PSI. Now notice that I was able to access the class attributes using the name directly. There are 2 types of references here you'll see. The first one is CLS. We use the class object that is passed in. I can also use the name of the class itself as I have done for car.psi. Car, in this case, references the same singleton definition of this class that class does. So, similar to a def statement, when we define a function, it assigns the function name to the function object. And in that same way, when we reference big C car, we are referring specifically to the class object. Let's take a look at another example. Here's a method that we've written called foo. What this does is it binds the block of code in foo to the name foo as a variable. We can print out foo and get our function, and we can print out car and see that it's a class. This is the way that Python stores information with the variables we define, as well as the keywords that we're using to create classes and functions. Names point to instances. Instances have a type, and everything in Python has a type. So, why don't we take our class method for a spin? I've got here car1 and car2. What I want to do is compute the tire description on each of them. And I can do that for both of them. I can also compute the tire description on the car class itself, because it doesn't refer to any individual instance of the car. Now, if we were to implement the same structure with our registry, what that means is that we could access our car registry from any individual instance of a car, but we could also access our registry from the blueprint class itself, big C car. Now, it's worth noting that although we can't access instance attributes from class methods, we can access class attributes and methods from inside instance methods. We just need to use the class name to access them. Let's take a look at an example. If we want to make a representation string for our car, you'll notice that this is an instance method. It takes in self, and it includes references to instance attributes like make, model, and year. But what it also does is it includes references to class attributes like the car's wheels or the tire description. And when we print this out, we'll see that we get a full description for each instance of the car that includes references to both instance attributes and class attributes. Now, let's talk a little bit about a common case where you might want to use a class attribute: multiple constructors. One reason to define class methods is to be able to define different ways to initialize an instance. Since there can only be one initializer in the class, we can't have multiple init methods in a class, we can't provide different ways to initialize an object with different initializers, like you could do in Java with multiple constructors, or Swift with convenience initializers. Instead, we might use a class method to convert strings with car data, like maybe that comes from a CSV file, that we want to turn into car instances, like this. So, we already can specify the make, model, and year in our existing initializer. But now we want a method to be able to create a car out of the string Tesla, Model 3, 1920. We're pretending the Tesla Model 3s were made in 1920 for this example. Please suspend your disbelief. Here we go. So we are making a class method, and we're going to call it FromString. What does that take in? Well, it's a class method, so first it takes in the class. Second, it takes in the string that it's going to be splitting up and using to create our car instance. Now look what it does. It makes a split on the string on the comma, and it returns a tuple, make, model, year. Now what we're going to do is we're going to call the initializer, this method that we already have up here, by referencing the class and passing in make, model, and year. This is going to allow us to make car instances out of strings, maybe that we got from a CSV. Take a look. Here we have 3 cars that we got from our strings, including our 1920s Tesla Model 3, plus a 2020 Ford Mustang, and a 2007 Hyundai Sonata. Now, various classes defined in the standard library use class methods in exactly this way. That is, to define alternate constructors. You know, for example, that you can create an integer by including a literal, like the number 2. You can also create an integer by converting something into an integer from another type of number. You can do the same thing with a float. That is, if you pass the integer 2 into a float cast method, then you're going to get 2.0 out, thus creating a float from an integer. But the float method also the float class also allows you to create an instance of float from a hex value. An integer allows you to create an integer from bytes. A date time allows you to get a date from a timestamp. Or you can get a chain from an iterable. You can get a signature from a callable. You don't have to worry about what all of these things are right now. But it's helpful to know that the Python programming language itself includes affordances for you to make the same type of object in several different ways. And the way that it does that is by leveraging the power of the class method.